Good morning, children. In today's video, we will solve a few examples on midpoint theorem and the converse of midpoint theorem. First example. So, this is triangle ABC, and M is midpoint of AB and N is midpoint of AC, and Mn is the line joining them, and BC is 8 centimeter. BC is 8 centimeter. This is 70 degree. This is 80 degree. Now we have to find. All this is given. So we have to find length Mn. What is the length of Mn? We have to find out, and then we have to find out angle M, value of angle M, and then angle N we have to find out. So how to find out this? So you know that this is midpoint. That means and N is midpoint of this. That means the line joining them is parallel to BC and also equal to half of BC. So Mn length will be 4 centimeter, and this is parallel to this by midpoint theorem. Therefore, these two will be corresponding angles. So this will also be 70 degree. These two will be corresponding angle. This will also be 80 degree. So how to write the steps? So we say that M is midpoint of AB given, and N is midpoint of AC. This is also given. Therefore, Mn is parallel to BC, and Mn is equal to half of BC. Which is equal to 4 centimeter. This is by midpoint theorem. In short, MPT I am writing midpoint theorem. I hope you understood. Mn is parallel to this. Therefore, angle M is equal to 70 degree. Angle M is equal to angle B is equal to 70 degree. And angle N is equal to angle C is equal to 80 degree. Because corresponding angles are equal. So I hope you understood how to write the steps. This is midpoint of AB, N is midpoint of AC. So we are applying midpoint theorem. By midpoint theorem, this is parallel to this, and this is half of the equal to the half of the base, which means it is 4 centimeter. These M and B are equal because corresponding angles are equal. N and C are equal because they are corresponding angles. I hope you understood. It's a simple this thing I explained here. Next, I will give an example for converse of midpoint theorem. What is given is M is midpoint of AB, and Mn is parallel to BC. Mn is parallel to BC, and this is 12 centimeter and this is 10 centimeter. AC is 10 centimeter. This is what is given. So in example 2, what is given is M is midpoint of AB. M is midpoint of AB, it is given, and Mn is parallel to BC. Mn is parallel to BC, and it is given, and BC is 12 centimeter. And AC is 10 centimeter. What you have to find? This is given. You have to find Mn is how much, and An is how much, and Cn is how much. You have to find all of this. So how to find? So here you see a line join from the midpoint of one side and parallel to the second side will bisect the third side. So that is the converse of midpoint theorem. So because of that, it becomes n also becomes the midpoint of this. So that means AN is 5 cm, NC is 5 cm. And now by midpoint theorem, Mn is parallel to this, and these two are midpoints. So Mn becomes equal to half of this. So Mn becomes 6. The length of Mn is 6. So how to write the steps? We write the steps like this. M is midpoint of AB, and Mn is parallel to BC. Therefore, N is midpoint of AC. Therefore, N is midpoint of AC by converse of midpoint theorem. And then we can say now this is the first part, and then we can say M is midpoint of M is midpoint of AB, and N is midpoint of AC. Now this is given, this is proved above. Therefore, Mn is equal to half of BC by midpoint theorem, which is equal to 6 cm. And now N is midpoint of AC. This means AN is equal to 5 cm and Cn is equal to 5 cm. So I hope you understood how we have done. I hope it's clear. This is another use of how we are using converse of midpoint theorem. So now we move on to the third example. Third example is prove that the figure obtained by joining the midpoints of adjacent sides of a quadrilateral is a parallelogram. So I take a quadrilateral. And take the midpoints of the four sides. This is P, this is Q, this is R, this is S. Now I am joining this. I am joining P adjacent sides, I am joining them. I am joining the midpoints of adjacent sides. We have to prove that PQRS is a parallelogram. We have to prove this. Now these two are midpoints, so I am writing like this. So I hope you understood. So this is example 3. What is given is PQRS ABCD is a quadrilateral. ABCD is a quadrilateral. PQRS are midpoints. Of AB, BC, CD respectively. AB, BC, CD, DA respectively. We have to prove that PQR is a parallelogram. PQR is a parallelogram. This is what we have to prove. So what we will do, we will construct what we will do, construction, join AC. We will make it into two triangles. So ABC is one triangle, ADC is another triangle. ADC is another triangle. Now what happens? Now in this triangle, if you see these two are midpoint, that means PQ is parallel to AC and equal to half of AC. Similarly, in this triangle, R is a midpoint, S is a midpoint. That means RS will be parallel to AC and half of AC. That means PQ and RS will be equal and PQRS will be parallel. So if two opposite lines are parallel and equal, it is that quadrilateral is a parallelogram. That is how we are going to prove. I am going to erase this and then write the proof. In triangle ABC, P is midpoint of AB given. Q is midpoint of BC given. Therefore, PQ is parallel to AC and PQ is equal to half AC. By midpoint theorem. This is the first part we write. Next is in triangle ADC. R is midpoint of CD. And S is midpoint of DA. Therefore, RS is parallel to AC. And RS is equal to half of AC. This is also by the midpoint theorem. I hope you understood. So now look at these two. PQ is parallel to AC, RS is parallel to AC. That means PQ and RS are parallel. So this I call it as 1, this is 2, this is 3, this is 4. So now from 1 and 3, PQ is parallel to RS. From 2 and 4, PQ is equal to RS. From 1 and 3, PQ is parallel to RS. From 2 and 4, PQ is equal to RS. So, in a quadrilateral, if opposite sides are equal and parallel, the quadrilateral in which the opposite sides are parallel and equal, is a parallelogram. Therefore, PQRS is a parallelogram. I hope you understood. So this is how we write the proof. Next we move on to the another example. Next example is a trapezium. It's a trapezium. ABCD is a trapezium and E is the midpoint of AD. And these two are equal, and there is a line I draw parallel to this, and it is meeting BC at F. We have to prove that F is midpoint of BC and EF is equal to half of AB plus DC. We have to prove. So what are the things we have to prove? Given is ABCD is a trapezium. and then E is midpoint of AD, and EF is parallel to AB. This is what is given. EF is parallel to AB. I have to prove that F is midpoint of BC. I have to prove this, and then I have to prove EF is equal to half of AB plus CD. AB plus CD. This is what I have to prove. I hope you understood the question. So now what I will do, I will join B and D. B and G, this is, let us say it is intersecting EF at G. This at G. So I hope you understood. Now what happens? This is parallel. So now first is E is midpoint and EG is parallel to this. That means G is also midpoint of DB by converse of midpoint theorem. Then in this triangle, G is midpoint and GF is parallel to this. That means F is also midpoint of BC by converse of midpoint theorem. That is one part is over. Now this is midpoint, that means EG is half of AB. EG is half of AB by midpoint theorem. Now G is midpoint, F is midpoint of this. That means GF is half of CD. So EF will become half of AB plus half CD. Like that it will become. So now I write the proof. Please understand this. That is, this is the proof. In triangle ADB, E is midpoint of AD, and EG is parallel to AB. This is given. These both are given. Therefore, G is midpoint of DB. By converse of midpoint theorem. This is the first part. Then in triangle DCB, G is midpoint of DB, and GF is parallel to DC. This is given. GF is parallel to DC, it is given. Therefore, F is midpoint of CP. So this is by converse of midpoint theorem. Two things, from these two things we have proved that F is midpoint of BC. I hope you understood. Next part I will erase it and write. So we have proved that F is midpoint, G is midpoint of DB, all these things we have proved. Now next is in triangle ADB, E is midpoint of AB, G is midpoint of DB. We have proved. This is given. This is proved above. Proved earlier. Therefore, EG is equal to half of AB, and also EG is already parallel. So EG is equal to half of AB by midpoint theorem. Similarly, in triangle DCB, G is midpoint of DB, proved above, proved earlier, and F is midpoint of CB, proved earlier. Therefore, GF is equal to half of DC. Half of DC. So, EG plus GF will become, this is 1 and this is 2. This is 1 and 2. This is also midpoint theorem. Now, if I add EG plus, adding 1 and 2. Adding 1 and 2, 1 plus 2 gives me like this. EG plus GF is equal to half of AB plus half of DC. Half of DC. EG plus GF is EF. EF. And this can be written as AB plus DC. AB plus DC. So EF is half of AB plus DC. So hence proved. I hope you understood. So if this is 10 centimeter and this is 8 centimeter, 10 plus 8 is 18, EF will be 9 centimeter. I hope you understood. Thank you very much for watching this video.